Hello everyone, welcome to Computer Science and IT Gate Coaching. Don't forget to subscribe my channel and press the bell icon to get the instant notification of my free lecture. So this is about me. I am a computer science gate faculty having more than 5 plus of teaching experience, mentored more than 50,000 students, taught in different coaching institute all over India. Okay, it's like the Gate Academy, even qualified multiple times Gate, and even I have given the coaching in many government colleges as well as in many private colleges. Like in SRM Chennai, I have given coaching. CAT Bhubaneswar, I have given. BC Bhagalpur, Jorhat College of Engineering, Guwahati University, Dibrugarh University, Government College of Engineering and Technology, Jammu, Ramgarh Engineering College. Okay, these are the colleges where I have went and I have given the coaching. We are going to see now explicit conversion. Explicit conversion. Conversion. So explicit conversion happen by using type def. It is now we forcefully want to convert into another type. It is done by using this type. This is unary operator. This is unary cast. It is called as by using. Let me write with a. This is done by using unary operator called cast. Name is cast. By using unary operator. By using unary operator called a. Okay. It is called as a cast. So syntax is like here you will write type name and here you will write the so it will convert whatever type you are writing, it will convert that. This is the syntax. Okay. So generally you have used this syntax in whenever you are doing dynamic memory allocation, when you are calling malloc. Okay. Then a into size of int. Like this, you are. I will teach you this. This also I will teach you size of int you are doing. Then it is malloc return void star. Now you want to convert it into int. So type conversion you want explicit. This is the explicit type conversion. Like int star you have done. Okay, this is the example. And in functions also we do the type conversion. That also I will tell you. Okay. The next point you write since an argument, since an argument, since an argument of a function since an argument of a function call is an expression. It is going to be expression also. I have told you the definition of expression. So argument of a function call is an expression. It is an expression. It is an expression. So you can even do the typecasting of that. So typecasting also take place when argument are passed to a function. So conversion, type conversions also take place. So type conversion also take place when argument when arguments when arguments are passed to function. So when argument you are passing to a function, type conversion will also happen. So in the absence of function prototype, if you have not given a function prototype, in the absence of, it is important, in the absence of a function, in the absence of a function prototype, the char and sort become int. Char and sort is going to become int. Char and sort become int and float become double. Float becomes floats becomes double. Float is going to become. Okay. That's why we have declared function argument to be int and double even when the function is called with char and float. Because if you are having see if you are not given a function prototype, if you have not given a function prototype, and char and sort will become int and float will become double. What I mean here means if you are writing some function and that prototype you have not given, you have given some function is equal to your int I you have given and some work is doing. I is equal to I into 2, like this you are doing. Okay, and you are doing something. Now if you are calling this function on 2, see this 2 is going to convert it into int. Why? Because it is in the definition. If you'll see, it is in the range of sort and char. It is sort, it is also in the range of sort, because sort is a small value of small data type of int. So this will get converted into int. This 2 will get converted into that. It is saying, see, in the absence of a function prototype, char and sort become int. Like if you, here you can call as fun a. So that is going to be converted. This is this is a character data type, but it will get converted into int. Okay. So similarly, if you are having fun2, and if it is having a, it is taking like, if it is taking like double, double, it's taking a double. Okay, double d, some work is doing. And if you're calling this function 2 by giving some number, like let's assume it is having some int f, so not float. If it is having a float, so it will convert float into double. Will convert float into double. Here also conversion is going to, if you're having a float f, and if you're calling, let's assume f is having some value, f is equal to 5.6 point something is there, and if you're passing this value, then it will get converted into double. F will get converted into double. Okay, see, float will become double. So in char and sort become int. In the absence of function prototype, char and sort become int, and float become, understood? Now see, this you have seen the explicit int star, you are by using this type casting you are doing, explicit conversion you are doing. Now now the precise meaning of a cast is of, is as if the expression were assigned to a variable of a specific type, which is then used in place of whole construction. Okay, so with example I will explain. Now, right, this point is very important. The precise, if you want the precise meaning of, the precise meaning, the precise meaning of a cast, precise meaning of a cast is as if the expression, as if the expression, as if the expression were, the expression were assigned, the expression were assigned to a variable of the specified, the specified, the specified type, which is, which is then used, which is then used in place, which is then used in place of the whole, place of the whole construction. So the precise meaning of a cast is as if the expression were, if the expression were assigned to a variable. So is as if the expression, if that expression is assigned to a variable of a specified type, which is then used in place of the whole construction. Okay. So with example it will be more clear. Like if you will see this square, that library function is square, that is going to square root. If you will use this library function square root. Okay, so a square root takes a function, takes a number. It's function prototype, its function prototype, function prototype is, this function prototype is return type is double and square root, and it is taking double. It's a function prototype, it's a function prototype. Okay, so whenever you are whenever you are calling this function on some number, like if you are calling this root, you are calling some root 2 on square root 2, it will convert this 2 into double, it will convert the 2 into double. Okay, it will convert this 2 to double, because its prototype inside the function, that is dot h, is written as, the declaration is that double. Okay, is it clear? So whenever you are calling, so whenever you are calling a square root on double, on integer, it will convert this square root by using double. This is the type casting is going to happen, and here it will have n. N is integer. N is an integer. This I am trying to tell you. So if you are having this is the square root function which is used to do square root of n. Okay. So if you are calling this function, if you are calling this function on int, it will convert into its, it will do the type conversion. It will convert this int to double. It will convert into double. So we have to convert this into double. Okay. Understood? So whenever I am converting this, whenever I am converting, like you have written, like you have converted before calling this, if n is an integer, if n is an integer, if n is an integer. Now if you are before calling, you are converting this, like if you are calling square root, okay, on double, you are here, you are writing double, and here you are writing n. You are calling this, okay, square root, you are calling this function, and you are converting this into double. It does not mean that you are converting int, sorry, it does not mean that n is going to be converted. It means that expression is going to be now passed as a double. Okay. So the cast, this is very important, don't get confused. The cast produces the value of n in the proper time. N itself is not changed. N is not going to change. Okay, n is not going to be changed. It is going to be converted. This expression is going to be converted. The cast, let me write the cast produces, let me write that the cast produces the value of, the cast produces the value of n in the proper time. In the proper time, let me write, then I will explain. The proper time. n itself, n itself is not altered. It's not going to alter. Okay. The cast operator has the highest, that I will teach you. See what I'm saying, that the prototype of square root is double. It will return double value. It is square root, and it is going to take some value which is double. It will take the argument as double. It is the prototype or function declaration of function declaration or function declaration. Okay. Now whenever you will call this square root, and if you are giving some integer, then you have to do typecasting. So you are writing the as a type, you are doing typecasting of this expression into double. So the cast produces the value of n in a proper time, means it will pass the value of n as a double, means it will pass the value 2 as 2.0, as 2.0, some double, but it will not convert to, it will not convert to, and n itself is not altered. Okay, so if you will print n, if you will print n, then whatever n was having, it will be as it is. Whatever n was having, it will as it is. It is not like n point 0. Understood? That I am trying to say. So cast is going to, where it is passing the value, that expression is going to get of that cast. Okay, that time. But it's not going to be, that expression is not going to change. What I mean, that if you are having like int float, okay, like malloc function where we properly use int star, we do malloc, and we are doing something, we are writing. So it is saying that whatever address you are doing, they are casting that, but whatever value it is having, that is not, this is not going to change. The value that is going to be passed, that is going to be changed. Are you getting that? Like if you are passing if double, if double and n, so n is not going to be changed. When you are passing here, it will store as a double. क्लियर हो रहा है क्या? पास करना, जैसे इसको डबल में पास करना, तो डबल होके पास होगा. एन अगर 5 रहेगा तो 5.0 होके चला जाएगा, लेकिन एन 5 का 5 ही रहेगा, एन चेंज नहीं होगा. समझ में आया क्या? टाइप कन्वर्शन क्लियर है सभी को? सो हमने टाइप कन्वर्शन में क्या क्या देखे, समरी एक बार बता देते हैं. हमने देखे कि टाइप कन्वर्शन हम कर सकते हैं, इम्प्लिसिट देखे, एक्सप्लिसिट देखे. ठीक है, एक रिकैप दे दे. टाइप कन्वर्शन में देखे, जो पहले देखे कि अपने आप जो हो जाता है. ठीक है. सो हमने क्या क्या देखे, जब डिफरेंट टाइप का ऑपरेटर तो टाइप कन्वर्शन होता है. नैरोअर टू वाइडर अपने आप हुआ, इनटू फ्लोट हो गया. ठीक है. फिर इसमें हम फ्लोट नहीं लिख सकते, ये देखे हमने. फिर जब हम लोग इसको जब हम लोग लोअर से देखिए दैट लाइक असाइनिंग इन लॉन्गर इंटीजर टू शॉर्टर में करेंगे तो एक्सप्रेशन कुछ लॉस हो सकता है, देखिए हमने ये। फिर एक रूल है जो सबसे ज्यादा इंपॉर्टेंट है, फिर कैर का देखिए, ये जो सबसे इंपॉर्टेंट है कि कैर को जब भी हम इंट में कन्वर्ट करते हैं तो वो नेगेटिव पॉजिटिव क्या होगा, मशीन डिपेंडेंट, ठीक है, वो हमने बताया आपको, बहुत इंपॉर्टेंट है। फिर हमने ये रूल्स देखा इम्प्लिसिट कन्वर्शन का, लोअर टू हायर कैसे कन्वर्ट होगा। तो रूल किस में कन्वर्ट होता है, जो ये कन्वर्ट होता है रिजल्ट, वो हायर टाइप में कन्वर्ट होता है, हायर टाइप में। तो अगर कोई भी ऑपरेंड हो गया, अगर आपका लॉन्ग डबल है तो वो सारे को लॉन्ग डबल में कर देगा, अगर डबल है तो सब को डबल कर देगा, तो वो सब हमने रूल्स देखे। फिर हम लोग अनसाइंड देखे, फिर हमने देखे यहाँ पे अनसाइंड में हमें कोई रूल नहीं है, ये मशीन डिपेंडेंट है। साइंड में सिर्फ रूल है, अनसाइंड में कोई रूल नहीं है, अनसाइंड में कोई रूल नहीं है, मशीन डिपेंडेंट। फिर एक्सप्लिसिट कन्वर्शन देखे बाय यूजिंग टाइप, जो यूनरी ऑपरेटर जिसको हम कास्ट करते हैं यूनरी ऑपरेटर, ठीक है।